Doing a lot of the installation on the ground at Milano and Company. Jess, I don't know if you have a few words
I don't have a mic, but that's
first
fine.
to say,
I've got a
but
loud voice, so.
there you
Oh, great. Yeah, I've worked for Milano and Company, and I've been doing most of the installs for our location in San Luis Rey, and then we also ran the flower fields down in Carlsbad off of it, so every one of the blocks down there had a sensor installed in it too.
So a little bit about the background. So what Mike is going to describe to you when you see the data on the computer is basically this is one of these satellite nodes, EM50G nodes. We didn't really talk about any battery life. I might as well just tell you about it now. Typically, battery life is, they've done a very good job of optimizing these nodes. Yes, they're batteries. Yes, I hate it from a kind of a sustainability perspective because they are Energizer, you know, the alkaline batteries. But they do last typically at least 6 months when they're in control mode. If you only send data once every 15 minutes, what I typically do is change batteries once a year. So they're very judicious in their use of power, and they do that by basically going to sleep between the times they take data. And then these 3G nodes, you set these up to go, I think they're 6 times a day. They will just send that up to the cloud. These are, I just brought up the prototype, and you can pass this around and take a look at it. So those nodes are very, very similar. That one actually does control, so it depends on how much it's controlling in terms of power. But the good thing about that is, and the software, as you'll see, you have a battery indicator on that. In fact, what we typically do is set up alerts, so it will just send you an alert if the batteries are going down, and you can set your own thresholds. Most importantly, though, what Jess has done, and I did laugh when he stuck this huge sensor in this little pot here. It's a little overkill. Actually, what I typically like to do is, he didn't have any other sensors. He didn't have these. So yeah, he only had the big. Pass this around. This is what they call a GS3 node. This is the one that does salt salinity. Be careful, they're sharp. It does temperature, water, and salinity. So that's what Jess has got in these pots. He's got them in here, as well as the hibiscus, Jess, and the mesquite over there.
And then one of those camellias right here.
And how long did it take you to kind of set up this node?
Well, other than me forgetting to check one of the boxes, about half an hour.
Half an hour. Okay. So the most important thing, there are some things to learn about sensor placement. What's interesting is you may wonder why we kind of didn't just stick it in the top of the pot, right? Why don't we just do this? Why don't we just stick it in like that? Any ideas why?
I don't know the depth accuracy.
It's all about accuracy, precision. Thank you. It's rooting depth as well. I'm going to stick this back onto me so I can actually do 2 things at once. When you've got very porous substrates in these containers, they're very light, very porous, very easy to over-irrigate. So what happens is that you've got a water profile in this pot, dry to wet, typically. And so if you stick a sensor in, you can do it this way, you can do it vertically. What you're doing is you're integrating more of a dry soil with a slightly wetter soil. So actually what we like to do is actually literally just punch this, actually do it with a knife usually. I punch it through and I actually bury the head in the pot. I punch it through at a particular depth because that's exactly what you want. You want to actually measure the same volumetric water content at the same depth. So that increases your precision of the information that you get. Little tips and tricks like that really make a difference. Also, when you actually put sensors in, you want to just do these sensors just to describe how in general they work. This is a little EC5 sensor, which is an analog sensor. This is kind of like its larger brother, 10HS, also an analog. These are dumb sensors, literally a dumb terminal. They work or they don't. Now, what's nice about them is they work on a high frequency, and so they're insensitive to salt, up to about 8 decisiemens. So they work very well in heavily fertilized situations. They also work great in soils as well. But it's really important when you put the sensor in that the thing that mostly affects these sensors is air. And so when you actually put them in a pot, you want to try and do is limit the amount of air that you get around the sensor, because that'll affect the reading. Now, it's easy to correct in this situation because all you need to do is give it a good irrigation and all of those soil particles will settle around it and you'll get a really good signal. In soils though, sometimes if you're putting it, like in an avo field, you're putting it down at 12 inches, Jess, you probably learned this, right? You put it in there and you get an air pocket around it, and you know, unfortunately we don't get a really nice good thunderstorm terribly often in California, and so you'll sit with that air pocket for a long time unless you literally dump a 5-gallon bucket of water on those sensors.
The GS1s, which are very similar to those GS3s,
Yep.
which are just 2 prongs instead of 3s, that steel is
You can
a lot
just
easier
get it
to
right.
in there than that
Exactly. So in hard baked soils, we actually do these. You know, it's pretty easy to break the sensor, so we try and do a good job on it. Now the GS3, wherever it is, in fact I can haul this one out. Actually I won't. There you go. Thank you. This is the steel prong. Now what this is nice is because it has this what they call a ruggedized housing. This actually is a lot smarter, the sensor. It's a little bit more intelligent. It's not greatly intelligent, but it has a 3-point calibration in it. This has a 1-point calibration in. They literally work or don't work. This one actually has electronics in it, which actually, out of the factory, will give you a much better resolution. So they do cost a little bit more, but honestly, I think Decagon and other sensor companies are going to more robust sensors because this will probably last 4 or 5 years out in the field. They're designed to actually set in place and actually be there in the soil for years on end.
So if you want to go 2 foot down, you just, how do you install it?
Good question.
Just dig a hole.
I just get a post hole digger out, dig a hole, stick a tape measure down there, and talking with John, if you put the sensors close to each other, sometimes they'll interact electronically.
Yep.
So I'll put them along the array of the hole like this, so they're separated from each other, so they each have a zone that they're reading from, moving up the hole. And then I've kind of standardized it. I do my deepest sensor in P1 and my shallowest one in P3, but that's just grower choice at
Preference.
that point. But yeah, it's simply throwing it in the hole and then repacking the hole to the same consistency, and then I usually leave about 6 inches for myself to pour water a couple times over it, and then fill that last 6 inches in, and you're good to go.
What do you replace the rocks that you dug out of the hole with?
There's stuff that's in my head.
No, I need a real inch.
Oh, the rocks though. Okay,
Yeah.
so if you're working in really
Really rocky soil.
like you guys are on the other side of the 15 going into Valley Center, what we would say to do is go into a region, first select a region that's load rocks, and then second, try to remember how that hole is put together as you're taking it apart and put it back together in the same fashion. So you have the same compaction rate.
Not
Tell-
gonna work that easy.
Tell
No,
you-
it's not. I
It doesn't
understand.
work that easy.
No, the
Ted-
rocky soil is a
Running
challenge.
into rocky soil, it doesn't
Yeah.
work that easy.
No.
That is a challenge. What typically, I tell you what we do is we don't fill the hole. In fact, we actually like to not fill the hole. What we'll do is we'll take a 6-inch auger on the back of a tractor or whatever. We'll actually auger a hole. The important thing is to get that hole as possible, and I know with rocky soils you're going to disturb it. Get that hole in, but what we do is we'll put a PVC pipe in.
I was just wondering if
It's exactly what
6 inch or an 8 inch.
put in a 6-inch PVC, enough for you to get in and get your arm down. And sometimes it's a bit of a hard getting your elbow in at 18 inches. It's a bit hard on the elbows. We'll cut portals in the side of the pipe at 6, 12, and 18. We standardize that. Literally get somebody with a Dremel or a saw, cut a portal in it, stick it down, and literally that's where, and then we make it easy. We just literally, sometimes they don't slip in, and sometimes you got to move the pipe around to not hit a rock. but that's how we do it. And actually then we'll just put a cap on the pipe. Literally just put a cap on the pipe.
Would you put a bottom on the pipe or not?
No, no, drain the pipe. Keep it drained. Now, one thing is that I can't help you with: rats, rabbits, coyotes, whatever. So
Cover would help.
So what we do is we actually run conduit, and my conduit is, we've all got it, a whole lot of probably 1/2 inch, 3/4 inch black poly that comes out of the irrigation field. We just slit it down, and literally I'll run a little trench to where my node is. Usually I'm situating my node fairly close to where I'm, and I just run this through conduit just to keep the coyotes and rats away from it, and that's it. Usually though, this is fairly close to I mean, you can do a starburst array depending what you want. Jess and Mike will tell you more about that, because what they're doing is they're measuring at depth, so we're interested in depth measurements. A good question that I often get asked is, okay, so where would you place sensors? Okay, I've got an avocado orchard. Where would you place the sensor? So I'm going to ask you guys, where would you place a sensor or a set of sensors?
Drip line?
Drip line.
At the drip
Why?
line?
Why?
That's where the feeder roots are at.
That's exactly right.
Right.
Exactly right. So if you've ever air spaded any trees out the ground, and I've done a few in my life, big 20 foot maples, even 2 years after they haven't been irrigated, there's a legacy effect of that irrigation line, and you'll find all of the highest root density is right along that drip line, or right around that. So roots go where the water are, that's where you'll sense. Okay, so if you're sensing, you don't need to be directly under the drip. In fact, sometimes it's better if you've got 2 drip emitters on a tree, or in a particular zone. Sometimes I like to put the sensor in the middle of those drip emitters, because what I want to do is I want to understand the water dynamics of how fast it's taking that water to reach that sensor, and at various depths, because that's really important to the longevity of your irrigation duration, right? You want to make, but I'm not sure about avos, correct me if I'm wrong, but I would say the majority of your roots with an avo, or any, in fact I know this from citrus, majority of your roots are probably in the first 12 inches. I would say 75% of your roots are in the first 12 inches. It's a pancake. We all think of tree root systems going down, deep roots, but there's not enough air down there for the roots. So they tend to be where the water, nutrients, and the air are. So yes, question.
Would you talk about how the readings you get, you relate to your soil? I mean, I use watermarks, and of course sandy soil is
Yep.
different than clay. And
Of course.
how does this work?
Well, that's a really good question. Watermarks, of course, work on soil potential, metric potential, and they're good. And I hope we can have I actually got another question about watermarks. So let's have a conversation about watermarks, because it's not just about this sensor technology; it's about any sensor technology. So these are capacitance sensors. They will measure volumetric water content. Decagon does have, and other companies do have, metric potential sensors, which are slowly replacing the watermarks and certainly the irrometers. Water availability is very important, and I think this is where the advantage is on watermarks, if you can get them to work well, is they work on osmotic potential. So you'll get a reading in 30 kilopascal, 50 kilopascal. And so for fruit producers, I think you're pretty in tune with that data. Now these will measure volumetric water content, which is a different measure of water. It doesn't measure availability of water, it measures the actual amount of water in the soil. So what I've started to do with the strawberry work is we're actually installing metric potential sensors with volumetric water content, because I think that the truth of it is that plant roots can take out a lot more water out of a root soil profile than we think they can. And so when you get up to 50 to 100 kilopascal, which is probably for this sensor maybe 15 to 18% water, volumetric water, we think it's dry, right? You stick your finger in that soil, it's pretty dry and hard. But those roots are amazingly resilient, and particularly if you've got a good root system, at pulling water out at fairly high tensions. Whether it has effect on fruit physiology, I'm sure it does. I'm not well versed in enough. It's been a while since my citrus days to understand at what point that becomes limiting to the tree.
So that's
I don't
just
know if that's
measuring the volumetric, just measuring that little area right where the sensors are.
Well, actually, the advantage is that this actually measures about a liter. So this is the type of sensor I like to put in a field application, because you're measuring about a liter. They've got a new SDI sensor coming out in a few months, which is actually going to measure about 3 liters. So obviously that's going to increase our precision of understanding amount of water, obviously because you've got a lot of roots in there and you might just hit an area which doesn't have a lot of roots. And so yes, it is a bit of hit and miss. That's why I like to do multiple sensors. And we'll really talk about that when we look at the data, because that's what Mike and Jess are doing, is they've got multiple sensors at similar depths, and now we can start cross-correlating that information. And particularly when you're looking at different crops like they are, you've got some pretty deep-rooted crops, right, with the ranunculus. That's pretty deep-rooted, isn't it?
That was surprising to us. We kind of learned that this year with the sensors, how deep those ranunculus are actually rooting for us. But our more important thing was we were able to actually visually see the movement from the drip tape to the edge of the bed. So predicting the irrigation scheduling where we weren't over irrigating and pushing water out of the bottom of the profile where the plants weren't actually using it, and we were only maintaining that top of the profile that the plants are actually using, while then doing our EC flushing later in the season. So we were able to do more of a timing irrigation where we were pushing that water to the edge of the beds with the pulses over the day, instead of just one big 45-minute irrigation set, which would give us that potential to get to the edge, but only at the end of that 45-minute set. So what we did is we put sensors at, we put them at 8, 6, and 4, going like this through to the edge of the bed, and that allowed us profile to see where the water was moving from the drip tape that was about at 2 inches. And there's 2 drip tapes within that bed, so we were able to kind of see a picture visually in a 3D. For the myrtle, it's one centralized hole. So in that case, we kind of thought about it as one plant is kind of the sample for the field, or multiple plants depending on what roots are in there, because it's a row of myrtle. And that centralized hole for us is giving us our data that we're using to irrigate that entire field. And we're trying to optimally water the root zone at 12 inches. And so we're watching where the water's being pushed to that 12 inches and not pushing it down to that 18 realm where we're not getting any water uptake anyways, and we're just pushing it out of the profile. So it depends on our crop, what we're trying to do with it. But it's for a lot of the avocados that we did on the property, we did it on the drip line in a centralized hole, because we're kind of basing it on one tree for the field. And then we probably put multiple sensors on different facing slopes.
So I don't know what you've just, what I love about working with Jess and Mike is they really exemplify what you can do with these systems, because they are learning systems. If you use them to understand your production and not be afraid of moving sensors around and learning from them, this is where it really gets exciting, because that then determines the strategy that you can use on much larger acreages. You don't need to sense, a whole production area. Take an area which is maybe something that you're very familiar with, learn what you are getting, the data that you're getting from that, and translate it out to other areas. That's the beauty of these things. Then when you think you've got a good handle on that situation, pick it up, move it away, move it on to your next problem area or your next challenge, because that's what they're designed to do. They're designed to be movable, scalable. If you want to leave them in place, that's where they really work best, because that's when you can, that long-term data, Mike will really show you, we're starting to get some nice long-term 2, 3, and 4 months data out of these systems. And I can tell you, I can't remember what I did last week. So being able to look at that data and remember and think back to what's happened a month or 2 ago, particularly in your crop development cycle, that's real gold for me. It's having that information, be able to look back on it and say, oh, That's what happened. Oh, now I understand. So,
Yeah, we did that. We did that a lot with the soil temperature for the flower fields. That affects those ranunculus heavily. Just a degree of change within the soil temperature could be the difference between 3,000 stems a week to 10,000 stems a week. So you know we're really varying on soil temperature. So when we were able to start monitoring that, we could look back and see, okay, now we have an idea next year when the soil temperature is going to increase to this point, what's going to happen in our actual production scale.
and I didn't have a clue about that. You know, understanding how soil temperature affects tuberization, and you know, it'll throw your crop vegetative on you. It's like, wow.
Yeah.
It's like, that's what I like about it. I like learning from you guys too.
Yeah, and well, and then did you want to talk about us burying them, or did you want to discuss that?
Bearing.
I buried these this year.
Oh yeah, sure. Talk about that, because
there was somebody
I'm
who
surprised
discussed
about that.
The security that we were afraid these things were going to get stolen. Well, I kind of have that down there in Carlsbad. We're such a public location. Kids love to pull on wires. So, for one, I was in the middle of the field, so I was away from people being actually able to molest them. But I do get people out there in the middle of the night, go out and try some flowers. So, what I did this year is I took 2 of those green valve boxes that you can buy at Rangettos or wherever, and hollowed out one of the lids, and then screwed that to the other lid, layered them, and then buried that about a foot under the soil. And they uploaded data, no problem at all. And that also allowed me, I could drive the tractor through those fields. My guys could pick through those fields. Nobody even knew it existed. Wires were under the ground. It was the only thing that we knew it was there is I put a stake so I could go back and find it.
Stop the tractor really growing over.
It'll really find it. So, but yeah.
That with the pipe that you buried in the field.
Exactly.
Is make it
Yep.
Yeah, it just covered that. This.
Even if you needed to for the transmitter, bring it up.
Yeah.
And one thing I tell you, they do have extensions on these, so you can put an extension cable between this and here. So you could actually run this. You could put this underground, just literally run the cable above ground. So they are designed to be
I
extendable.
have another question. Do they have to be vertical or horizontal?
Ah, great question. Sorry, I forgot completely about that. Well, if you're going to stick this sensor in, don't do it like that, because you're going to create a dry area beneath it. So we typically do stick them in vertically, just to minimize that shadow. But more importantly, I think what's really good to know is, and anybody who's interested, I'll pass this note. They sometimes have a lopsided field of measurement. So on this 10HS sensor, golden rule is 10HS down, because that will then. So if you realize that and you're going in at 6 inches and you want to measure 6 to 8 inches, put the 10HS down and you got 6. So I put this in right at 6 inches, and then I know what I'm measuring. So.
Now with the GS the same.
GS3s are actually a bit bigger. So the field of volume on this one is it's not quite a liter, about a quarter gallon, but it's about this area. So typically what I like to do, again, thanks Jess, I'll pull one of, sorry Dustin, see if I can get it out. So actually what I like to do with this particular sensor is I try and disturb the ball as little as possible, but I create a little space for it and get that sensor nicely buried in like that, and literally just pop it in like that. Because that way your head's buried, keeps it cool, you don't have any problem with electronics, particularly containers. You know, black container, 140 Fahrenheit in the afternoon if it's sitting in sun. So it can get toasty in there. That one I did horizontal, and that was because basically because I got the metal prongs, and because I'm not creating any shadow with that. Yeah, so good point. Also, I like to do that because I want to measure temperature, water, and EC all at the same level. Yep.
So in the field's the same way.
Same way, yep. But this sensor, different, because it's got a sizable, you'll create quite a dry area beneath this, particularly if you've got a drip emitter on top of it. So that's why I tend to do it this way. Yep. Any other questions? Yes.
So that's the 3G model itself.
Mm-hmm.
Do you need a monthly subscription?
Oh, good question. Yes. So when you buy this, they give you the first year for free, and then the subscription on that works out to be $10 a month for the cell service.
Through
So-
AT&T.
through AT&T and T-Mobile, I think. Now, what I typically do is I check the coverage map. So if you go online, you can check coverage maps. I actually asked them, the Decagon folks the other day, they actually are in the works of bringing out they use a Rogers SIM card. They're going to another SIM card, so if you have a different carrier, they are working on that. Not quite sure what the timeline on it. If you've got better Verizon service, then it'll work with Verizon, yes.
Do they have sensors so they can I can come up and manually route it? Because I've got a problem in the area we live. I can have two people with their cell phones 5 feet apart and they can't talk to each other on my property.
Yeah, that's the nature of
They do have a
3G.
COM port on them, so you
So-
can manually.
Yep, you can actually test telemetry. Have you tested the telemetry?
I've tested all
Yep.
these. So, in
how does
here,
that-
there's one more port on that one. I know you guys saw that other one where it says COM port. That's where you hook it in and actually like tell it what sensors are hooked up to it, tell it how often to do the interval of reading, how often to send it to the server. But in there, once you're hooked up to it with your computer, and it's just it's a USB on one side and that headphone jack on the other, you can look at it right there and then.
There's a little program that they send you. It's a free program. It's called Echo Utility, and that's where you actually will check your telemetry. Sorry, I totally zoned out on that question. Yes. So if you've got a node situated, that's probably the first thing you want to do. Get your laptop, open up Echo Utility, stick it there, and test your telemetry.
And the thing is it might,
Or get Jess to come and do it
or
for
they
you.
have a tester. They have a little. It looks like an old Game Boy. And you just hook it in.
Two or three of them that you can come out and look at and I can read what's in it and write it down.
Yeah.
That's what's going to work for me if I use something because
Right. So in that situation, what would probably be easiest for
my
you?
Wi-Fi is all my stuff is wireless, and that's why I have a landline cell phone. There's a landline phone.
Yeah. So
I can use.
So in your situation, it might benefit you to have the tester, because the tester, you plug it in, reads out what everything is reading currently. So all you do walk up to it, plug in, it would show you, pop out, and you move on to the next one.
Let's move on in. Sorry.
I got one more question.
Yes.
How long will the data stay on the system?
Oh, great question. So, in fact, what I typically do is you can erase your data. Depends on how often you're logging. If you're logging in a 15-minute period, you'll have about 12 months of data on that node. It's resident. Again, I'm lazy. I never X out the data on the node because actually I treat that as my security. I actually is getting everything in the database. If I have a problem in my database, at least I know that I've still got the node, and it will overwrite the oldest data first. So it's pretty smart about that. So you've always got this kind of bank of data which is at least resident. I'm pretty retentive about backing up my data from the database on my computer as well. Yep.
And you can download it as an Excel,
If you
There's
want to.
all kinds of downloads for it. It has just a picture of the actual graph. So, and the Excel is really nice because you can pop it out and it's well formatted where you can go back in there and mess with the data yourself if you really wanted to.
Yeah. I hate Excel. I hate data. I just fall. It's like this instant go to sleep. It's like I've got to visualize it. For me, it's like it's got to go into some kind of visual form and be aggregated. Otherwise, I'm out of there. I don't have enough time in the day. Sorry, I'm lazy. Anyway, let's go on in because Mike's got a Mike. Well, and we'll talk more as well.
Okay.
Yeah.
So